Marine biology and oceanography are two related fields of study that focus on the oceans and the life within them. Marine biology is the study of marine organisms, their behaviors, and their interactions with the environment. This field includes the study of all kinds of marine life, from the smallest plankton to the largest whales. Marine biologists investigate the physiology, behavior, and ecology of marine organisms, as well as the ways in which humans impact marine ecosystems. Oceanography is the study of the physical and chemical properties of the oceans, including their composition, movements, and interactions with the atmosphere and the land. Oceanographers study everything from the tides and currents to the chemical makeup of seawater, and how these factors affect marine life and the global climate. Both marine biology and oceanography are interdisciplinary fields that draw on a range of scientific disciplines, including biology, chemistry, physics, and geology. These fields are important for understanding the health of the oceans, predicting the effects of climate change on marine ecosystems, and developing sustainable management practices for the world's oceans. Ocean movement, also known as ocean circulation, is the movement of water through the world's oceans. There are several factors that influence ocean movement, including wind, temperature, salinity, and the topography of the ocean floor. The movement of ocean water can be divided into two categories: surface currents and deep currents. 1. Surface currents. Surface currents are driven by wind, which creates a flow of water at the ocean surface. These currents are influenced by a number of factors, including the Earth's rotation, the shape of the ocean basins, and the location of continents. Some examples of surface currents include the Gulf Stream. This is a warm ocean current that flows from the Gulf of Mexico along the east coast of the United States and across the North Atlantic to Europe. The Gulf Stream has a major impact on the climate of the eastern United States and western Europe. The North Pacific Current. This is a cold ocean current that flows from the North Pacific towards the equator. It is responsible for the cool, dry climate of the Pacific Northwest region of North America. The Antarctic Circumpolar Current. This is the largest ocean current in the world, and it flows clockwise around Antarctica. The current plays a critical role in regulating global climate by transferring heat and nutrients throughout the world's oceans. 2. Deep currents. Deep currents are driven by differences in temperature and salinity, which cause dense, cold water to sink and create a flow of water along the ocean floor. These currents are much slower than surface currents and can take hundreds or even thousands of years to complete a full cycle. Some examples of deep currents include the North Atlantic deep water. This is a deep ocean current that forms in the North Atlantic as cold, dense water sinks and flows southward along the ocean floor. This current helps to regulate the global climate by transporting heat and nutrients throughout the world's oceans. The Antarctic bottom water. This is the densest water in the world's oceans, and it forms in the Southern Ocean as sea ice freezes and leaves behind high salinity water that sinks to the ocean floor. This current is a major driver of global ocean circulation. Overall, ocean movement is an important process that plays a critical role in regulating global climate, distributing nutrients and heat throughout the world's oceans, and supporting marine life.